Okay, let's look into what are different types of algorithm. So algorithms can be either iterative or recursive. We can say an iterative algorithm is the one that is comprised of loops. So it repeats, there is some repetition over, there are different loops, so there is repetitions everywhere. And in a recursive algorithm, that algorithm is a small piece of code, but that code repeats on itself. So that is the difference. So iterative algorithms are where there are the loops, and loops are sometimes computationally expensive. So we observe that recursive algorithms are more efficient and quick as compared to the iterative algorithms. We can also define a correct and an incorrect algorithm based upon what it's doing. So if it's giving you the required task, that is correct. And since in algorithm there are large number of steps, so if there is some issue or there is some problem with any of the steps, we can say that algorithm is incorrect. Fast algorithm is the one that performs the action quickly, as the name indicates, whereas the slow algorithms are slow. So here, since technologies are changing, so we are not concerned about the actual time it's taking, but here we can classify this problem with the help of the number of steps involved. So if there are more steps involved to solve a problem in one algorithm as compared to another where there are less number of steps which are involved, so maybe first one is taking more steps, so it is expensive, computationally expensive as compared to the second one. So we can define that algorithmic problems into on the basis of their number of steps they take. So here is just a glance for the computational complexity. So there are different algorithms here, and we can say the complexity of the algorithm is some function of some input. We can say, we can define here, say some variable. So here we can take this variable as input size x. So there is one algorithm, its complexity is going in a logarithmic scale. The other one is we have square, right, and the other one is cubic. So the complexity of this algorithm depends upon the cube of this variable. So which one is computationally expensive? So if we look into the left hand side of the graph, so here are some input sizes which are 0 up till 12, and here are some computing or computational steps or sometimes intervals. So we can say that in the beginning, as we observed, that log has more complexity. So log is actually taking more steps, but as the input size increases, the cubic is going higher. So here, if we look into those small constants like 6000, 11, 99 something plus 7, so under small inputs they might be having some effects, but if the input size is increased, we would see that these figures, these additional figures, they might not mean much to our problems.